Hello friends, now we'll see IPv6 addresses and its packet format in detail. So in the first section we had discussed why there is a need of IPv6 addressing, as the extensive use of IoT, Internet of Things, as the devices wants to communicate with each other by using the networking facility, so that we have to assign the addresses to the devices so that they can communicate with each other efficiently. So that's why we move towards the IPv6 addresses. So as in the first section we had discussed, IPv6 address consists of 16 bytes, and we are using here hexadecimal colon notation, which can be explained with the help of this figure below. So here you can see that 128 bits of addresses, in which there are uh, 8 hexadecimal units of 2 bytes each. So 2 into 8, that gives you how many bytes? 16 bytes. So the abbreviation is very important, as we had discussed in the first section. Also, abbreviation can be used as means what, if the address is not abbreviated, then we can say that if it consists of zeros, then those zeros will be involved in the not abbreviated section, but if it is abbreviated, then the zeros can be eliminated. So that we had discussed earlier. Also, there is the use of CIDR notation, by which can have the three types of categories of addresses that can be used with the IPv6, in which unicast defines a single computer. When there is a communication in between the two machines, or a single two single machines, then we are using unicast. Then if we have the anycast, then it defines a group of computer with addresses that have the same prefix. Means what? For example, you're saying that WhatsApp group. So the group consists of what? The peoples or the persons associated with that group. So once you put the message to a group, that message will be percolated to all the group members. Then multicast defines a group of computers that may or may not share the same prefix and may or may not be connected to the same physical network. So these three categories of addresses are supported by IPv6: unicast, anycast, and multicast. So this can be used, this can be asked for your examination, examination, as what kind of addresses are supported by IPv6. So unicast, anycast, and multicast. So here is the best example of how this abbreviated and more abbreviated section is used. So see in this figure, the actual address consists of FDEC BA9000000000000000FFFF. After that, it's not abbreviated. In abbreviated section, you will find out that the 4 zeros can be abbreviated as a single zero over there. So it becomes 000 and then FFFF. And in the more abbreviated part, what we do, we'll eliminate the zeros and put the 2 colons over there. So that is the more abbreviated address. So the question mark in front of us is that many of us would be thinking that it supports hexadecimal address or decimal address. So mostly it supports hexadecimal addresses, mostly like saying that it supports hexadecimal address, but for example it is given in the decimal format as well. But its meaning is not like that it supports decimal addresses or the combination of hexadecimal and decimal addresses. So these are the examples just giving for you to have the difference in between unabbreviated, abbreviated and more abbreviated. So don't look at that in that way that it consists of hexadecimal and decimal addresses like that. So just focus on the zeros, how to eliminate the zeros and how to add the colons uh, uh, colon in place of the zeros. So the IPv6 packet format compared to IPv4 packet format, many of the fields are eliminated in the IPv6 packet format, and these packets are as follows. As we say that it consists of 128-bit packets. So in that we'll see one by one this fields. So in that first field is a version field which consists of 4 bits, which indicates the IP version number. It is same as the IPv4, but here in the binary format it represents what, 6 instead of 4. So in IPv4 it is 4, in IPv6 it is 6. Then the second bit is priority, that is what, 4 bits. So it specifies the priority of the packet with respect to the traffic congestion. Means what? So we say that if the congestion is there, then what happens, the network, in the network the hops or the nodes are trying to send the information to each other, and there is more traffic. So we can set the priorities, which nodes can communicate first, which nodes can communicate later, like that. So in that way this priority bit can be used to set the priority. So in the situation like congestion, what happens, the priority set nodes can communicate first and others can wait for them to complete the communication. So that is the actual use of this priority bit. Then we have the flow level, that is of what, how many bits, 24 bits. So it is similarly as the flow control. Means what, the sending and receiving parties can communicate with each other at the same speed. So it is designed to provide special handling for a particular flow of data. As we know that IPv6 more of the time we are using audio and video, live audio and video. So in that case the flow can be maintained, so that this flow label bits are too much, that is 24 bits. After that we are having payload length. So it is of 16 bits. It specifies total length of IP datagram excluding base header. So here what we are using, here we are using the virtual circuit. So virtual circuit will do what, it establishes first the path to the destination and it does the communication. So payload is of 16 bits. The next header is of 8 bits. It specifies the header that allows the base header. It may be one of the optional extension header or an upper layer protocol header. So in this the next field is hop limit. It is of 8 bits, similar to the TTL field in the IPv4. TTL stands for time to leave packet. After that I'll have the source address field, which is of 128 bits, and the destination address is of 128 bits. It generally specifies the final destination of datagram. However, if source routing is used, so this field contains the address of the next router. So we'll look in detail about the extension headers. What are the extension headers? And the following extension headers have been defined in IPv6 standard. So in that, first extension header is hop by hop option header. It defines special options that require hop by hop processing. So hop is what? The next destination. So for example, we had discussed these things in the trace route command. So if you trace the route up to the specific destination, then it shows that the hops how you can reach there to the destination. So that is hop by hop processing. Then routing header provides extended routing. Fragment header, so in IPv4 there is directly the fields like fragmentation and reassembly. So here fragment header supports the fragmentation and reassembling information. So authentication header provides packet integrity and authentication. So that is about the authentication. Encapsulation security payload header provides the privacy in between the communicating parties. And then destination option header contains optional information to be examined by the destination node. So what are the extension headers that we will see in short. So extension headers are supplied to provide extra information but encoding in an efficient way. There are 6 kinds of extension headers at present. Each one is optional, but in case of more than one header is present, they must appear directly after the fixed base header and preferably in the order listed. So we'll see these extension headers. So in that, hop by hop header is used to send information that all routers along the path must examine. So in that you can say that how the path has been established by giving the information about each destination in detail. Then the routing header enlists one or more routers that have to be visited on the way to the destination. The fragment header deals with the fragmentation in a way similar to IPv4. Then authentication provides a mechanism to the receiver of a packet to be sure of the sender. Means what? Whatever the sender is sending and the receiver is getting, then receiver is giving the response to the sender, saying that whatever the sender is sending is going or receiving to the receiver, or we can just say is received by the authentic receiver, not the hacker or the intruder in the network. Then the destination option, this header is intended for fields that need only be interpreted at the destination host. So these are some of the extension headers. So these are the 6 extension headers that are used in IPv6. So friends, thanks for watching this IPv6 addressing. So this IPv6 addressing and its packet format can be asked for the examination. So prepare for it as and what is the purpose of extension headers, and what are the 6 different types of extension headers that you can prepare for the examination. So thank you for watching. So we'll see the remaining part, that is what transition of IPv6 addressing and ICMPv6 in the next section. So till now we'll stop here and see the remaining part in the next video. Thank you.